In this video, we're going to look at how to find values that make a rational expression equal to 0. The directions for number 1 say evaluate the following for the value x is equal to 3. So for a, we don't have any x's in this expression. So we have 0 over 4, which is equal to 0. In b, we have x minus 3 divided by x minus 2. So we'll put 3 in for both x's, so we have 3 minus 3 divided by 3 minus 2, which is equal to 0 over 1, and 0 over 1 equals 0. In part C, we're going to have 2 times 3 minus 6 divided by 3 minus 6. And 3 times 2 is 6, so we have 6 minus 6 divided by 3 minus 6, which is equal to 0 over negative 3. And 0 over negative 3 is equal to 0. So for D, it says, what do you notice about the numerator in each case? Well, if we look at the numerator in each case, we have 0 over 4, 0 over 1, and 0 over negative 3. So we can see that the numerator in each case equals 0. In E, it says, what is the value of the expression when the numerator is equal to 0? In each of these, the numerator was equal to 0, and we said that each of them was equal to 0. So the value is 0. For number 2, we want to solve each equation. And the first one, we have x minus 4 is equal to 0. So we'll add 4 to both sides, and we end up with x is equal to 4. In part B, we have x minus 4 divided by 3 is equal to 0. And we learned above that if you want the equation to equal 0, that we set the numerator equal to 0. So we'll have x minus 4 is equal to 0, and x is equal to 4. And in part C, we have x minus 4 over x minus 8. So we're going to set the numerator equal to 0 again, and have x minus 4 is equal to 0, and x is equal to 4. Now in this equation, we have x minus 4 over x minus 8. So we found that the numerator is equal to 0 at 4. But we also need to check and make sure that the denominator does not equal 0 at 4. So if we put 4 into x, we get 4 minus 8, which is negative 4. So the denominator is not equal to 0, which leads us into our next discussion. It says the rational expression p over q equals 0 if, and we know it equals 0 if the numerator is equal to 0. So p is equal to 0. And then we just talked about that the denominator cannot equal to 0. So we're going to say that q cannot equal 0. And then the solution of the equation p over q is equal to 0 are those values for which p is equal to 0 and q does not equal 0 again. So we can see that in order to make a rational expression equal to 0 is the same as making the equation of p over q equal to 0 as well. And in 4, we have find all the real values for which the expression is 0 if possible. So the first thing we're going to do is set the numerator equal to 0. So we have x squared plus 5x plus 6 is equal to 0. And now we want to write this in linear factors. So I'm going to write this as x plus 3 and x plus 2 is equal to 0. And now we can see that x is equal to negative 3 and x is equal to negative 2. And now we need to take a look and see if these values make the denominator equal to 0. And here we have 3x squared plus 1. And if we square the x term, it's going to make it positive, and it's times a positive number and plus 1. So this denominator can never equal 0. So this expression is equal to 0 at negative 3, negative 2. In the next expression, I have 5 divided by x minus 7 times x plus 8. And if we were to set the numerator equal to 0, it's just 5. And since 5 can never be 0, there are no x values that make this expression equal to 0. And now we want to solve each equation if possible. So in order to solve this equation equal to 0, we're going to set the numerator equal to 0. So I have 5 times x minus 6 times x plus 4 is equal to 0. And then we can set each factor equal to 0 individually. So we have x is equal to 6 and x is equal to negative 4. And now we need to make sure that 6 and negative 4 do not make the denominator equal to 0. And our denominator would be 0 at 7 and negative 8. So our denominator is not 0 at 6 and negative 4. So this equation equals 0 at 6 and negative 4. For b, we're going to start with setting the numerator equal to 0. So we have 5x times x squared minus 4 is equal to 0. And now I want to write this in all linear factors. And we have a perfect square here. So I have 5x times x minus 2 times x plus 2 is equal to 0. And now if I set each of these factors equal to 0 individually, I find that x is equal to 0, x is equal to 2, and x is equal to negative 2. And if we look at our denominator, the denominator would be 0 at 4. So since 4 wasn't any of our answers, we can say that this equation is equal to 0 if x is 0, if x is 2, and if x is negative 2. And that's how we find values that make rational expressions equal to 0.